Fine. So we got familiar. We know now what is dependency inversion. We know why this class depends about. In the previous video, have a look at it if you haven't yet. We already reviewed the project in general. We got familiar with the clean architecture, with dependency inversion that is utilized within this class. We know the domain, we know application modules. Now we know how this class doesn't know anything about outer layers and still is able to interact with it using dependency inversion. Now let's go through and just review what was generated with the coding agent. Okay, at the first glance, it's already good that it depends only on the abstractions. Then we have the core state of what is the responsibility of the alarm controller class. Let's start from this point. Whether it satisfies singular responsibility principle. The responsibility is the only one reason to change this class is to change the way we control alarm in our application. Basically what it does, it starts alarm, it stops alarm. Quite simple, quite narrow responsibility. Well scoped, I would say. How it's done on implementation layer. I mean, you know, this is abstract layer. How it's done on implementation layer. We have this state of this instance, of this class instance, and the state will have inside what's actually going on, whether the state is idle or active. So basically whether we are actively listening to the battery level or we're not. We have getter, we have a private setter, yeah. In that case, we encapsulate settings, but we make it visible for the client of this class. We make it visible. We make this state possible to get through this public getter. Yeah. So basically, we can. Someone can get this state. Someone can start the alarm. Client of this class, the one who uses class called client, should know about the reason why we start. What it does first, start alarm. We have a look if in settings it is enabled. If it's not, we return wait. Start alarm. Okay. So one step back. The responsibility of this class is not to save this state whether user enabled observing battery level. But responsibility is to start and to stop actual alarm screen. Basically, this is like remote control we use to start phone screaming and waking you up in the middle of the night and tell battery is dying. Put the cable inside, make it charging. So that was controller is doing, and it's doing it with these two functions. So we know whether it's screaming, whether the screen is opened and there is vibration and sound, like basically how alarm works, or if it's not screaming. We call the state idle. Yeah, okay. So as when system tries, let's say we observed in the broadcast receiver that battery level is low, we start alarm. We check if actually it is allowed in our application. If user allowed by clicking the button enable alarm, if user allowed alarm screaming, if it was not allowed by user, and we know it by repository, by persistent storage, if it's not allowed, we return disabled. Basically, we does not allow application to screen because user didn't allow it. If it was, function continues, it's fine. I approve this line of code. Let's go further. We check what is the current state. Basically, are you already screaming or not? If you're not screaming, if the state is not active, then, oh wait, if the state is already active, we return it and we don't proceed with initiating alarm again, just to avoid, let's say, opening two screens with two alarms, with two vibrations, with etc. Good, this is a good gate. And only if it's allowed, only if screaming is not happening right now, we create this new state, we set it to our variable, we start sounds, we start phone screaming, we started vibrating, we notify user, and we return for the caller of this function result, which is active. Good, I approve this. And when stop, also something like that is happening. Let's review it. Fine, current state, blah blah blah, whether it's, if it's active, if it's not active, we say it's already idle. If it is active, we prepare the state, we stop sound, we set we stop vibration, we stop notification. Okay, kind of fine, correct? I have only one concern with it. My intuition says, wouldn't it be better to set the value only after we already actually stop phone from screaming? Would it be better to set the value after we start screaming? Just to make sure, what if, just to prevent the case when we already set a state that, let's say, that it is screaming, but actually application crashed at this state. And we saved, but we already saved inaccurate state, which is not accurate, which is not correct. It's not screaming, it's not vibrating because we crashed in here, but we already saved as active. So I would say it is better and cleaner and safer to assign the value after the job is done. So I would change it. I would do like that and like that. Is it fine? Is it enough? Kind of. Kind of. Someone would return current state, but actually it is more explicit and readable to duplicate started. Oh wait, this is a different instance. Yeah, we one instance we assign to this one, and another very different class, sealed class, we return. So I take my words back. It's fine. And it's the only way to return started in here. Fine. Okay, I approve it, and I tell Codex push it. What is important to review now is to go unit tests and to see if what is verified, because AI may generate useless tests or unsafe tests. Let's review them as well while Codex committing pushing. So see, what is the advantage of before we go to the unit tests, an advantage of the dependency inversion and make instance depend on the abstractions on the interface, not on the implementation, is that we can safely substitute implementation and we can mock implementation of the interface for the tests, because we do not, it's when we unit test this class, we should test this logic, but not what is going on inside alarm vibrator or alarm notifier. So we mock external interfaces and we verify only what's going on in here. And that's basically how any unit test is test is executing and is implementing. So are you running? Yeah, everything is run. I didn't break anything when it changes this line of code. It verifies that the state is expected. It verifies basically I want to make sure that the unit tests verify each if statement. We have 1, 2, 3, 4, 5, 6, around 7 tests, correct? We have 1, 2, 3, 4, 5. Yeah, kind of. Okay, number kind of match. Does match the number of possible variants. Having yeah, so I'm reviewing what it does. It does verify if start alarm activates and start output. Start alarm activates alarm and start outputs. Okay, I don't like this naming. It's not very clear what's going on. So I make the first change. I tell my agent is the way how to name, and I ask it for unit tests. I want you to have to adhere the following naming convention for the test function. When, then. When this precondition, then that happening. Because now it's kind of just saying what's supposed to happen. It's not very clear. Change the naming. Fine, it will do the job now. Meanwhile, I'll continue. So, what are the preconditions of the unit tests? Vibration, blah, blah. What about a repository? Ah, okay, it's enabled true. So it goes through this return statement. And the state is, what is the current state? And by default, the state will be idle. Okay, that's why it goes to this one, and it verifies that this line of code that we calls at least once that the state changes accordingly, that we activate state, we activate vibration, system low battery notifier. Okay, fine. When alarm is enabled, then start alarm activates like sounds and vibration. Fine. Good point. When alarm is disabled, then start alarm lives in idle state. So see, we check, we validate, it's fine, good. We validate that this is never called. Basically, we check if return statement, but if user did not allow alarm to happen, then we do not proceed with these functions. Fine. Then again, starts, more we start. We still working testing start function. When alarm is already active, fine. Basically, it what I wanted. It verifies this, if it's true, if it's false, then this, if it's true, if it's false. I believe, so it's 1, 2, 3, 4 for this function and 4 for another function. And I believe it should do something like that for this one. Again, correct. 1, 1, 1, 1, 1, 1, 0, 0. Fine, fine. Okay, very brief review, but I like how it's done. I can trust this unit test, and I can already rely, and if it does something in the future, the test will be broken, and I will be notified, wait, business logic that you wanted to have is broken. That's why we need unit tests. So fine. Push to the remote. See, I have initial, I have domain alarm, I have format domain alarm, and now I'll have another commit. Good. Kind of good. What we'll do next, we'll see in the next video. We should actually implement anything. We should bind our UI, we should create UI, and we should bind it, connect it with our controller that we already created with the business logic. We should activate all this brain we already created for our application. And we'll do it in the next video.